course, the one and only Robbie Diamond will be joining us up here just in a second.
Good to see you again. Good to see you. Yeah, thanks for coming. Oh, good, really good. As you can. Yeah.
I ran into Delaware for the DC show.
Oh, okay. Right. Yeah, great to see you too.
Yeah. VIPs in the front row, only VIPs in the front row.
Stay away.
Wasn't with the company today, but I heard a lot of the stories.
Barry, you qualify as a VIP. Get on up here.
You very make a speech to that.
All right, well, thank you everybody for joining us. I'm Jason Conley. I'm Executive Director of OmniAir Consortium. I just wanted to say thank you to SAFE and Securing America's Future Energy, as well as DC CarTalk, and the folks at the Mobility Podcast for helping bring this event together. I'm told I'm not holding the microphone close enough, so hopefully this is loud for you in the back of the room. And for those joining us on YouTube, I understand this is being live cast on YouTube, so if you do have comments or questions, just very briefly about OmniAir Consortium, we are an association that's focused on promoting interoperability and certification for ITS connected vehicles and tolling. We have members that do work in the tolling space on RFID, those that do devices that are DSRC based, and those that are developing devices that are in the CVDX world. From a testing perspective, the vehicle connectivity, whether it's DSRC or CVDX, is really about 90% the same. So we're going to take a fairly agnostic approach and a technology neutral approach. But one thing that we're not agnostic about is the need to preserve the spectrum, the full 75 megahertz that's better known as the safety spectrum. And I think that's why we're here tonight. And you will see a diverse panel of views from engineering firms that are involved in US DOT-sponsored connected vehicle pilots to companies like Toyota that are pushing ahead on DSRC, those like Ford that have a big vision, and Qualcomm that have a big vision for CVX. And I think you will see that this united front of companies and organizations that are out there with a unified voice talking about why it's so important to preserve that spectrum. And as many of you know, the Federal Communications Commission has an open rulemaking proceeding. That open rulemaking proceeding, comments are due on March 9th. OmniAir is working on those comments. I'm sure that many of you in this room are working on comments as well. And hopefully you'll learn something this evening in this robust discussion that will help to inform those comments. Just one note that we had the Diana Hirschkopf-Roth, the Deputy Assistant Secretary for U.S. Department of Transportation, was scheduled to speak with us this evening and offer opening remarks. She unfortunately has been waylaid by other events. Having served time in a previous administration, I certainly understand how those things come up last minute. But we're so glad to have Robbie Diamond, who will be offering some of the remarks that she would have made and talking about the importance of the safety spectrum. I just wanted to introduce very quickly Robbie, who will introduce the panel. Robbie is actually the founder of SAFE, Securing Energy, America's Future Energy. This organization is really unique in Washington, and we had a good chance to chat beforehand. And I was telling him that I spent part of my career in the national security, homeland security space, and part of it in the ITS space, and usually it's a very different cast of characters. And it's really, really great to see an organization that talks about the impacts of the transportation choices that we make on our foreign policy, our engagement in foreign wars, and our policy for energy. So the SAFE has been a leader since I think 2008, and Robbie is our founder, and helped to propel this message forward about the need to have to explore other options: electrification, connectivity, sharing, autonomy. And so it's just a real pleasure and a distinct honor to be co-hosting this event with SAFE. And without further ado, I'm going to introduce Robbie.
Thank you, Jason. Thank you all for being here. This is a new space for us. We're trying more to do these events. If anyone has an interest in hosting and co-hosting with us, we'd love to have you. Diana Frischgott-Roth, of course, sends her apologies. I will not answer questions. She was going to do that. I will not give her a speech, but I think I will channel, in my view, some of the thinking that she's had about this. You'll all, if you've met her, have to envision a British-speaking person, so that because I won't do the accent for you. I guess more and more in Washington, we all scratch our heads and we ask ourselves, like, why are we even having this debate? Like, what is going on here? And I think this is like one of those issues. The more you know about it, the more angry it can make you as a citizen. And I think if more citizens actually knew what was going on, they wouldn't believe it. And this is an issue, and I apologize for people who really know this issue are in the room, but I do think a few people online should get some of the background. This is an issue that every single American will be impacted by, from the newborn that's currently being driven. 1,000 people die on our roads. 2.7 million people are injured. It costs the United States of America over $270 billion in direct costs and over $800 billion in indirect costs. Most people have been impacted themselves. For myself, my grandmother was killed in Ann Arbor when I was younger by being hit by a motor vehicle. That would not have happened, most likely, if they had this technology back then. 2 decades ago, the FCC actually was wise, and they set aside 75 megahertz of the 4.9 gigahertz band, which they called the safety band, a band that was supposed to be used that would ultimately save people on our roads. And they felt that this was important enough to set it aside. In the last 20 years or more, people have been working on this issue, which we'll talk about. It just hasn't laid fallow, as they like to claim. The DOT has sponsored projects, car companies, cities, and for this, they really this funding was relying on what they call uncluttered intervening uses by non-licensed types of devices. We carry them all around, and this depended on a clear wireless signal, helping cars avoid accidents. And as we all know, it only takes the smallest fraction of a second for something to go wrong. And, for the last 25 years, from 2004 to 2012, you've had the Institute of Electrical and Electronics Engineers working on standards. It doesn't happen overnight. 2016, the Society of Automotive Engineers comes out and completes their standards for governing performance requirements of data elements for 2 types of technologies, the DSRC and a new one called Cellular CV2X. And this is rolling out all over the United States. 38 states have licensed projects, active licenses. Unbelievably, there's 498 other projects currently sitting at the FCC. So if they actually got those out, maybe we would actually use more of it. Just a couple months ago, the FCC puts out roaming of the spectrum. It over to this, and then they're going to 30. And if you're just left RC, and then it's 20. That connect autonomous vehicle research today. Interference. Devices could interfere. I asked the question, allow about planes in the United States die on our roads. That 2767, they're on their heels, and yet we don't say anything about this. So, will the federal government and citizens? It's hard to see how we benefit. So the question is, like, why do we care here at SAFE? Now, we were lucky enough to take our name, Securing America's Future Energy, actually known as SAFE, because now we actually want people to be safe. How to do more with the space we have, and this technology will allow us to do that. It will allow us to deal with congestion in a safer way. We just did a study on current technologies that showed, because we believe, as you heard, economic and national security reasons. Too many of our battles have been fought because we need one commodity to fuel our global mobile economy, that's called oil. And so we showed, or we put forward and said that you could save 18 to 25% fuel just with current technology if our cars were actually talking together, because it would be a more efficient system. You could save 9,000 lives on our road. So we see this as critically important to, even in current technology, to meet our mission's objectives. Secondly, we do believe in a connected, autonomous, shared electric future. We think this is very important. And these could be the building blocks for that future, certainly connected, but even autonomy. Yes, it's true, we use LiDAR and radar, and we don't usually currently maybe not use this, but we all know that a little more information into those cars talking to each other can just make them safer. So if it's complementary, great. But we just don't even know yet. So why do something that will set back both the country's future and endanger us as we compete? Which gets to the third point of economic productivity. So here we are. We want to be this strong power, and other countries are setting aside their spectrum. They're not, right when the technology's coming here, handing it out. Canada, for example, also has the exact same spectrum as I actually come from Canada originally. I would like to take my car and drive to my parents. Actually, I think I'm doing that in like a month. It would be nice if the technology worked here and worked there at the same time. And that's what our cars do. So not only Canada, Europe, China, all these have set aside their spectrum. Fourth, and as I started, it saves lives. And our mission is to save lives on our battlefields, but I do believe it's also to save lives on our roads. And this is the way to do that. If you had autonomous vehicles, based on not just in the United States, you could save 3,000 lives a day, based on just over 90% of our accidents being caused by human error. I would think if there's any drug at the FDA that could save that many people, we'd be, just rushing it through. And here we are with the technology on the cusp of doing just that. I mean, just look what's going on with coronavirus, how much money they're about to spend, how quickly they're going to move. It just pales in comparison. Not saying we shouldn't do that, but we need to ask ourselves that question. So I do think as a society, we ask ourselves, what are our priorities? I think we should keep the blood off of our streets and keep it maybe on our Hollywood screens, even if that just takes a few seconds more to download. If the FCC goes fast, I think just we'll all be a little more furious, and we wouldn't want that. So with that, why did I call up the panel? Tweet that. Okay, let's call up the panel and let's get started. And I'll introduce the panel.
Place to put my beer here.
That's why we need autonomous vehicles. Because I think they get the connection. So let me start. I will not introduce an order. Steve Novosad is the VP of HNTB Corp, which is chair of the OmniAir Consortium. Thank you, OmniAir Consortium, for hosting with us. He works on ITS issues for 35 years experience in systems and software, 22 years on ITS. And he's the chief engineer, lead, on the Tampa-Hillsborough Expressway Authority Connected Vehicle Deployment Project. Phew. I should probably shorten that, make it a little more spiffy.
Theia.
Alice Tornquist as VP on Spectrum Technology Policy at Qualcomm. She deals with technology and spectrum issues. And she has led issues on getting a digital TV transition, broadcast incentive auctions, and ITS. She used to be on the U.S. House Transportation Committee and at OMB. Thank you for joining us. Ed Bradley is the program manager at Toyota. He's a motor vehicle safety engineer, incredibly important job. And he works on the regulations related to connected and autonomous vehicles. And he's been 25 years in the auto business and 21 years in the company. Wanted to for can happen used by these unlicensed. I guess I laid out some of the costs to the country. I guess what are your views? Each of you maybe share some thoughts on the cost benefit analysis and like what widespread V2X can help us with. Start.
Sure. So just a little bit on Qualcomm, in case people aren't familiar. We are the largest provider of chipsets for mobile devices. We've been working on wireless technology for the 35 years of our company's history, including 3G CDMA and a leadership position in 4G LTE, and we've been working on 5G for the last 10 years or so. We have been very much engaged in C-V2X over the last several years in a number of ways. We've been working through the standards body, 3GPP, that has brought forward the release 14 version, what we call basic C-V2X, as well as future versions, release 16 and 17, which are underway at 3GPP right now. And we're part of an association, a global industry group called 5GAA, the 5G Automotive Association, which has many members here represented tonight, that's working on advancing C-V2X around the globe and has over 130 members. And we've also been involved in the FCC spectrum proceeding. In terms of the capabilities for V2X, in our case, our interest is in C-V2X. We think that they are very promising. And in particular, our purpose in working over the past several years on advancing C-V2X is because of some of the advantages that it brings forward in terms of range and reliability that we think will be very important in roadway scenarios where these types of communications can help prevent accidents.
So the question was on the economics.
Give us a sense of the cost benefits in your view, because the FCC says there's all these benefits by giving it away, but I think we have a lot of benefits by keeping it for transportation.
So I think by the cable and Wi-Fi industry is the RAND study that they commissioned, where I think it was $100 or $200 billion in economic benefit, would be enabled by this. I think you can make up or come up with numbers on both sides of this argument, depending on how you want to look at it. I think on our side, and you had mentioned some of the numbers that I know DOT has spent some time thinking about in terms of not only the lives lost, but what we would call the orchestration benefit of employing V2X in whichever form. And how many, millions of barrels of oil, that will save, how much time that will afford, how many more lives in addition to just traffic fatalities, but think about lives that are lost within an ambulance that's speeding to a hospital and can't get through a lane. And the signal, if these vehicles were connected, a clear path that could be created for that. So there's all these unintended or uncalculated benefits that could still result. And so I think, you put enough creative people in a room, for a day, and you can come up with a rather large number, right? I think one of the primary arguments we would make is that what's unique about the 5.9 band is that it's globally harmonized to a large degree. And in addition to Mexico and Canada being able to travel freely between those states, for manufacturers, the benefits of scale and being able to put in devices that are globally harmonized is tremendous. I mean, it makes it more affordable. It becomes standard equipment on vehicles. And it's important to us. I mean, China right now is leading in this direction. They've dedicated 20 megahertz to C-V2X. They've got 13 or 15 OEMs committed to doing it. And we believe that, us, the US, Europe, others could be falling behind here in this respect. And with regards to Wi-Fi and cable, there's other spectrum they could explore. Some of you have heard me, talk about the 6 gigahertz proceeding, and there's 1.2 gig of spectrum there. And I know there's utility companies camped out in various portions of that spectrum. But I keep telling them, the cable Wi-Fi folks, to go east, young man. There's 1.2 gig of spectrum there. The 45, I understand why it's precious real estate here, because it makes some of the channels contiguous and makes it more efficient for them. But the 75 megahertz should be retained for safety, and I hope it is.
So I'm a systems and software guy, not a numbers or cost benefits guy, but one of the things that I think is very important that people haven't thought about in terms of being able to recoup benefits is just think about all the truck traffic we have on the road and the delays that are caused by congestion and accidents, and just be realistic about it. Those things drive prices up, prices that come out of our pocket. So for me, it becomes more personal, if you will, in that if trucks can communicate with the infrastructure and with each other and other vehicles, and they can be rerouted, not sitting on, I-75 in Florida for 6 hours because it's closed and they didn't know to get off, or anything like that. I think that there's tremendous economic benefit for everyone in that role.
So I'd like to reiterate what Steve and John have said. I'm disappointed that they haven't really taken a close look at the opportunity cost in taking away this portion of the spectrum. Again, they don't consider the lives saved, the injuries reduced, the crashes reduced, and the resulting improvement in congestion and fuel economy based on reduced crashes. Vehicle safety connectivity, the way we envision it, using the entire spectrum, can ultimately address up to 80% of non-impaired driver crashes. So we see a huge opportunity here to reduce crashes.
I think that's one of those unlicensed devices getting in the way, the wireless way between your voice. So, see, we didn't put anyone's lives at risk, and we still showed interference.
Although I'm becoming impaired. So.
That's why I think autonomous vehicles, like, have we gone out to the beer companies yet?
Yeah, that's right.
Current use, the FCC says that if we should do this because this megahertz remains fallow. So I guess Steve, in the idea of remaining fallow, you work on a project in Tampa that I can't name, but you'll rename for us. Can you please just tell us about that?
Sure. So in Tampa, the Theia, which is Tampa Hillsborough Expressway Authority, was one of the 3 CV pilots that were selected to demonstrate how the technology can be used in the corridor and actually do evaluations. We've been actually at this project for almost 4.5 years. The Theia project is coming to an end here, hopefully in a couple, 3 months. And we've been generating terabytes and gigabytes and all kinds of bytes of data that the US DOT and our performance measure folks are looking at. The pilot itself is all about connectivity. And there's 2 forms, right? There's the V2V, so we're using all the standard apps that you might be familiar with, which is forward collision warning, emergency electronic brake light warning, intersection movement assist. And I'll just stop there and say, you've never been in a demo until you've ridden in a car that's going to do an IMA with a bus. And the bus comes out of nowhere. and you have to stop it. It'll get your heart going. But so we use those types, and we also have V2I apps. And so while, we believe that the OEMs, the Fords and the Toyotas and the Hondas and such, are going to take care of the V2V part, right? That's what they're going to do, and that's what CAMP is about, and being solidarity about that. But then there's the V2I apps and the IOs, the infrastructure owner-operators. What do they get out of it? And so we're looking at apps like pedestrian crossing, where we're tracking pedestrians and broadcasting personal safety messages to cars to basically alert them of a potential collision. We're using something we created called end-of-ramp deceleration warning, which is really saying that there's a big queue backed up and we're warning you to slow down. And Theia is actually looking at propagating that off just the pilot site to other ramps. We also do wrong way entry, which is, to me, a very simple application using the map and SPAT from the RSU that just sets a bit and says, hey, the car gets that bit, knows it's in the wrong lane, and a warning goes up. So there's a lot of effort going on in terms of safety and mobility. Theia in particular, what they look at is how does it benefit them, in terms of service to their customers, and what value do their customers actually get out of it. As I said, the pilot's winding up, and we're producing a lot of data that ultimately will be scrubbed and cleaned and made available on the public USDOT website for people to download and access.
So as a follow-up, were you surprised at what you discovered?
Yes and no. I'll be honest, in the beginning, we had, in all three pilots, I'll say, had the impression that the apps were much more mature than they were. And so that was an eye opener. But once we got into it and started working with the vendors and got it going, the ability to communicate and exchange messages and do things has been really impressive. We do a lot of demos. We get a request for a lot of demos from different people, and they're always very impressed with the way the cars react to each other and things. So some of the V2I apps are challenging just because there's so many variables that you have to deal with.
For our home audience, V2I, vehicle to infrastructure.
Vehicle to infrastructure, V2V is vehicle to vehicle.
There we go. Ed, why don't you tell us some of your experiences at Toyota using the technology GSRC?
So what I'd like to talk about is sort of build on what your first question was about the spectrum, the claim that the spectrum has been followed for a long time. And really, the auto industry takes much longer to develop and prepare technology to be introduced into a vehicle than a typical consumer electronics product. And this process has taken quite a bit of time to do the research and development with USDOT funding to prepare the technology and to confirm that it can actually work as envisioned for these safety applications. So I think that's been the bigger hurdle as to why the technology hasn't been introduced earlier. And then the NHTSA was preparing a rule that we were all watching and following and thinking that was sort of going to be, or the requirement that we would all have to meet for the vehicle-to-vehicle technology that would also be able to be used for V2I and I2V. So I think there was several other things that were happening that are unique to the auto industry because of the environment that the technology must work in a vehicle, and especially for safety applications.
John, do you have some thoughts? You guys made a big announcement at CES last year, and maybe tell us a little bit what's going on.
Sure. So we announced at CES 2019 January that we were going to deploy C2X on our vehicles for V2X communications. We intend to start doing that in 2022. And then within a few years after that, nearly all of the 2 million plus vehicles that we sell here in the United States would be enabled with C2X. So the reasons that we had done this, because as Ed said, the industry was working on DSRC collectively because it really was the game in town first probably 17, 18 years of the 20 that we're talking about since the spectrum's been granted. But as our engineers came to evaluate the technology, we saw improvements in latency, we saw improvements in distance, we saw improvements in the ability to see around corners. And for us, it was making a bet on something that we felt would provide, even higher levels of the benefits that we've been talking about because of the capabilities of it. The other important reason that we chose C-V2X was its clear pathway to 5G. And so knowing that protocol is going to be available and provide even larger amounts of data carrying capacity, with the coming of autonomy, and again, not knowing, as Robbie pointed out in his remarks, how AVs may be able to get data on those lines, and we need 5G band is one of the spectrum.
This question, I can ask another one.
Quickly on that with John, I mean, I think the NPRM believe that the spectrum make a compelling case for it's going to offer up standpoint the compelling case. That's see that enabling be done, whether it's intent sharing, important automated vehicle, and then in the V2X, there's a lot of work being done on V2P, improving that and making that more useful for consumers and automobiles. With all the fatalities that have been occurring and the rise in pedestrian fatalities and bicycle fatalities, we really do want to take advantage of all of those capabilities, and wider channels are going to be needed for that. And so making that case at the FCC, we think is going to be really critical to have a future-looking policy for this band.
So what's interesting about Qualcomm is, your phone, you make things for phones and now for cars, and so, the FCC says they want to reduce from 75 to 45. They present it as a win-win situation. And I guess my question is, could this not reduce the effectiveness for both? Like, why is it not necessarily a win-win? What they're saying, what is this idea of interference, and why is it a big problem?
Okay, well, there's a couple things in that question. Why is it not a win-win? Because by allocating the 45 megahertz to unlicensed, it's precluding the wider channels that we think will be necessary for the 5G versions of C-V2X. So taking that away from these capabilities that we think will really have significant benefits for transportation safety. So that's the answer to that. In terms of interference, we will also say at the FCC that what they have proposed for the 45 megahertz with the unlicensed, the rules that they're suggesting for that need to be, if they are going to go forward with that, they need to be adjusted so that the remaining portion of the band continues to be useful for transportation services.
And maybe just spend a second talking about, I don't know if you want someone else, just about this whole interference question. Like, are you going to impact the effectiveness of both? Meaning, like, why is it such trouble? Explain maybe interference to people who might not otherwise know what this is.
Yeah, go ahead.
I'm not the network engineer up here, but it's Wi-Fi is at least in this band and what's been intended for safety messages is not necessarily the best neighbor to have because of the nature of the signal and the long tail that it has. As Alice said, with the way that the NPRM is presented, we would see major interference, certainly in the 10 megahertz right above the 45, and still it would be existing, in the upper 20 that they've allocated for C-V2X. So it's somewhat counterintuitive that they would want to, not have the spectrum be fallow anymore for safety, but potentially render it uninhabitable. So interference is a very big concern of ours, and therefore, we have to look at what is the best way to alleviate it. Well, the best way is not to even have it in the band whatsoever, and to preserve some of that spectrum for growth.
I don't know if either if you want to answer, I have another question.
Actually, I'd like to talk a little bit about interference because we had some direct, the pilot had some direct experience with that. And we were going through a lot of testing, and we actually had a big deal with USDOT a couple of Junes ago, and everything was working great. USDOT came and nothing worked. And after we did some analysis, grabbed some of the data, we found out that there was a ham-wham guy broadcasting on our channels, and it was a continuous stream. We couldn't, the way the SRC works is it listens and then broadcasts if there's an open spot, and there was ever an opening, so none of our messages were getting through. So, kind of going to the whole interference thing, if you're talking about safety of life, and we're broadcasting message 10 times a second, and one or two of those is lost, that can be the difference between the crash and not the crash. So I think that's why interference is a big issue.
So then I have to ask the question, which I started with, which is, sometimes in Washington you ask the question, like, how is this even possible? I don't know if any of you want to speak to, like, how does it work that the FCC, after hearing these compelling arguments, feels that this is something that they should debate and potentially move forward? It just seems to me like any reasonable person wouldn't think like that.
Well, I would just say the NPRM is the beginning of a process at the FCC. So no final rules have not been written. So this is a process in which they're trying to collect comments from people who have information, which is why it's important for people to step forward and make those comments. So their ultimate mission is to, as they've stated, take a fresh look at the band, ensure that it's allocated optimally, and make the best use of it. If their proposed technical rules, as we believe, are not optimal, it's incumbent on us to step forward and say they can be adjusted in such a way to accommodate the various services that have been proposed. But again, it's a public proceeding. It's intended to collect comment and weigh those comments, and then there's reply comments. No decisions have been made. To the extent they got it wrong with these technical rules, it's incumbent on us, I believe, to step forward and explain that before it's too late.
Anyone else want to take that? The question of what's going on? Why? If not, okay, I have a question for companies. So here you are, they've said, oh, we're going to open it up, we're going to look again. How does that put a chilling effect on, like, you're making massive bets for the future? This has been going on for 25 years. I think Toyota made an announcement and Toyota reversed its announcement. So give a sense of, like, yeah, it's great that they keep looking at it, but if they keep looking at it, what does it do to the decisions that your companies and the bets you're willing to make?
So I'll start that, excuse me, what we've been saying since we announced a pause on our deployment is we have to have the regulatory certainty. And the reason is cars last a long time. And we have to ensure that the technology that we put in the vehicles for this important safety connectivity will be viable and will continue to work for the life of the vehicle. And once we're assured that the spectrum or that the communication will be permitted for the long term, that's when we'll start taking action and developing plans for deployment in the future.
So, and I will say that, if you have been following this space, and I think most of the people here that would be drawn to an after-work event on this are very informed about this, right? So I'm not going to be educating anybody here. But we had as part of 5GA as well, and because we had made this commitment to deploy the technology, we had to find a mechanism to get C-V2X on the air, because currently it's not sanctioned to be in the 5.9 band. So through 5GAA, we applied for a waiver, and we're getting nowhere with that. So when the proceeding was announced, Robbie, to answer your question, it was like a good news, bad news situation for us, because it was like, great, the FCC has recognized C-V2X. But you know, I'm going to have a teenager with a very big stereo next door, you know, broadcasting out it. I'm not going to be able to use the band as intended. And we are talking about the safety of life. You know, there is no room for error in this. And I think one of the things I've found out over the last year, because prior to coming back to DC in this capacity, I've learned a tremendous amount from not only my fellow panelists, but a lot of people in the room, is the paradigm in which some of these are looked at. Because when you talk to folks in the cable industry, they look at an incident rate that's very different than the way the auto industry looks at it. You know, we're planning for 6 Sigma plus incidences of non-failures. You know, you think about the cycles that our parts go through in terms of testing. And then a cable guy goes, well, you know, there's a 1 in, I don't know, 20 chance or 1 in 30 chance that the signal may happen. And we're, well, that's unacceptable when we're talking about transporting people and lives. And, you know, we're going to make attestations of the fact that it's going to protect pedestrians. So we can't have that kind of error rate. And that's one of the differences between these two, is just the lenses at which you look at failure rates, right?
I have a great idea for you. Who saw the movie Ford versus Ferrari? You know how they put the CEO, Mr. Ford in the car, and they drive like crazy around, and he's so scared at the end. He's like all in. You should take the chairman of the FCC, put him in a car, drive him around crazy, bring another car, and show him how he can have a failure. Maybe that won't work. But hey, why not? Maybe speak to us about the competitiveness of the United States. We're all about making America great. I would think that this might be not good for us in comparison to if others are doing something different.
Yeah, I think, you know, looking at other parts of the world, China made an allocation of spectrum to CB2X last year, and the same 20 megahertz that we had proposed in the waiver through 5GAA at the FCC. And shortly thereafter, a number of auto manufacturers stepped forward and made commitments. So that's an example of what can be done when, when the correct allocation is made from our standpoint. And it arguably places, China in a better position than we are with this, with regard to this particular area. So I think there is a competitiveness issue there as well.
And I think, if you were going to continue on this, at least from a C to X perspective, China is leading there. We have this proceeding happening in the U.S. You have Europe, whose member states, had sent back a plan that was going to be one technology centric. So everyone's taking a look at this, kind of evaluating it, and everyone's kind of in a different phase or a different place with it now. But I think that's part of why it would be a travesty almost to take the ban away when we are on the cusp of actually being able to utilize a full 75 megahertz, and I would argue in probably 15, 20 years time, we need more spectrum than that ultimately.
I'll come at it a little bit from the safe perspective in that with this technology, while we still have gasoline engines and diesel engines, we can reduce fuel consumption with it, and we can reduce emissions with it because we can have platoons of cars moving through intersections. Green wave, I'm sure you've all heard the term green wave. So there's not only opportunities for safety of life, but in mobility and environmental. And if we're going to be a competitive global country, we have to worry about those types of things. Other countries are moving forward in a lot of different ways and using different technology. I know we have our own bureaucracies and things, and different governments to handle things differently. But we have to stand up and take a stand and try to get this moving forward so that we can accomplish things and it can create jobs, right? I mean, people are going to need to build these devices. Qualcomm makes chips. They're going to need to make chips, and so we can create jobs and become a much more competitive country, I think.
And we have been in a leadership role with the research and development that's been done with the original incumbent technology, DSRC. So there's no reason why we need to lose the lead on safety communication technology in vehicles.
And maybe share some thoughts on your thoughts. And it was mentioned, I think John mentioned the idea of AVs and the use of some of this. And I know everyone talks about LiDAR and radar, but there's a whole other communication of cars speaking to each other. So maybe share like what happens if we give this away, you can't do this, and then realize, oh, maybe we do need more of this communication. What happens to that side of this? And then Ed, I think you want to speak to that.
Yeah, I can see. So there is a lot of talk about this issue, and we see in the future increasing levels of automation being added to the vehicle to assist the human driver to make the driving experience safer, to make the driver safer. And as we increase higher levels of automation in the vehicle, we see connectivity as being an additional important sensor to the vehicle, in addition to the LiDAR, radar, and cameras that are on the vehicle. So we envision as the technology increases, the need for V2X connectivity will increase.
And I completely agree. I think in addition to the three senses that Ed had mentioned, telemetry, photo, I'm sorry, he mentioned radar, LiDAR, and photo, and I always add telemetry as well because the vehicle has to have a sense of where it is. AVs will be that fifth sense, or connectivity will be the fifth sense for the AVs. And it's important because you think about what we're trying to achieve with autonomous vehicles today and the amount of technology that's on board trying to operate as an independent device. How much of that can we push to thinner and thinner clients, make the technology forward and more deployable? Infrastructure may have to pick up on some of that. And a lot of those capabilities that are sensing on board right now, just like we all used to have very heavy desktop computers, that were standalone devices. Once they become connected, you don't need software anymore, right? You're using Google Docs, you're using everything from the cloud. It's going to take a long time to do that, I think, with autonomous vehicles, but you're going to need spectrum in order to have that kind of connectivity and share the kind of data I think that's going to be required to actually realize that future.
So I'd like to just take a different perspective as a everyday person that knows a little bit about both. And so with autonomous vehicles, certainly the capability, and there were some autonomous manufacturers whose names will go unmentioned that came out and said, we don't need to be connected. And so my challenge to them would be very simple. You get in your unconnected autonomous vehicle, I'll get in my connected autonomous vehicle, and we'll head to the airport. And there'll be a major crash on, I don't know where the interstate is, but 395. And it's closed. And so what's going to happen to the unconnected vehicle? It's going to go right into the congestion. The connected vehicle will get the information, reroute, and get you to the airport on time. So that's one perspective. The other is that all the sensors and everything on the vehicle, I kind of look at it as if you look at bubbles, that's a small bubble around the car. And then you add connectivity to it and you get a much larger bubble. Now you can see around corners. Now you can see further down the road, or here, or however you want to put it. But you're getting that data, so with the intelligence and the AI going into these vehicles, they'll be able to determine, maybe even predict crashes, I think, at some point.
It's a network effect. Yeah.
So I guess we're dealing with an agency where car companies don't spend a lot of time. It's not your agency. And we've all heard of that, and maybe no one wants to take this question either, but just what's it been like working with the FCC, and are we at a permanent disadvantage because we're not there every day, or you're not there every day?
I'm going to get into the FCC pro here.
I have colleagues who are at the FCC every day, so I don't know that I'm exactly the person to answer that question. We've been working with the FCC since the very beginning of our company for 35 years. So your question is, what's it like for an automaker?
Yeah, I mean, I think like you would with anyone who's a new congressman or congresswoman, and you're educating them on issues. A lot of it is educating them about our space and what's capable. And it's not just the commissioners; it's the technical staff as well. It's one of the reasons we had our event out last June up near Howard University during ITSA's annual conference, was to just show people what the technology is capable of on a surface lot there. And that to me is the best thing that we can do, is just show them actual use cases. And so that has been the biggest part for me. It is a new agency, but they understand our concerns now. They've been very approachable. It's a different set of rules. There's a lot of formality around filings every time you meet. And I'm glad I don't have to do that every time I head up to the Hill, file an ex parte. But it's been a good conversation this past year for us.
Yeah, so it is very different. I've worked for decades in the auto industry, and in a regulatory capacity, more in connection with NHTSA, National Highway Traffic Safety Administration. And they're a very than the FCC is. So for me personally, it's been a little bit different to learn about them and how they work. But we have outstanding colleagues at Toyota that have been doing a really excellent job in working with the FCC and communicating with them with our concerns and developing excellent comments to this NPRM that are due early next month.
And I guess just from my perspective, not being an OEM, but when 25 years ago, when these guys were building cars, and of course they're forward looking, but looking at our roadways, we were worried about what? Asphalt, concrete, pavement markings, signage, and things like that. And I think certainly in this explosion of technology in the last 10 years with the smartphones and all this connectivity, what has come to be true is transportation, I think, has become the key to almost anything we do. And in that, transportation people have had to learn to work with people and agencies and companies that they never thought they would in the past. So this isn't the end. I mean, the FCC is the current thing that we work with and try to figure out. But there will be something again next that we have to deal with.
I always like to say that that companies have been grappling with that, right? Their new competitors and everything else. But I actually think in Washington, we have all these outdated organizations, mine excluded, but all these outdated organizations, and they, there are these siloed things like all the environmental groups, and there are safety groups, and then there are, there could be, mobility groups. And the truth is that these things are now all intersecting. So, just as like we watch companies on the run dealing with their new competitors, we should be watching these organizations have to reinvent themselves as well. And it's frustrating because they're educating our, policymakers in the sort of the old ways instead of talking. So I think that a little shout out from my team here, but our team's been great because really we like to run this place according to the Jerry Garcia idea. He once said, someone's got to do it, and it's just pathetic. It has to be us. And so we're like technology agnostic and everything else, and like we just want to go. And if it's we now need to rename ourselves safe and be about safety because that's an advantage you can have, and you can have fuel economy. Well, we should talk about that. And if you can get disabled people or elderly or poor people to a job or to the hospital that you couldn't before because of this new technology, well, we should talk about that. And I think that hopefully Washington catches up to the way the companies have had to grapple with a new world. So I guess my last question would be, is there a path forward for preserving the entire spectrum? And are you optimistic, pessimistic, or you're just going to take a pass? Ed, why don't you start?
I'm optimistic about it. I think it's so important for transportation safety. I think the comments that the FCC are going to receive in early March, and then the response comments will help maybe influence the decision on this. And I think we're pursuing also some other mechanisms for thinking out of the box of a way of preserving this 75 megahertz safety spectrum. So I'm very optimistic about it.
Well, I think that we have the opportunity here to get this preserved, and can we do it? Absolutely. I think the outpouring of I participate in a lot of committees and a lot of meetings, and everybody's writing comments and everybody's saying the same thing. And so I think there is a wave or a movement now beginning to say we have to preserve the spectrum, and maybe we demand it. That said, if we're victorious, it can't stop. It's got to continue to wave. We've got to continue to go forward.
Meaning deployment.
Meaning deployment.
Yep. I would wholeheartedly agree with that. I am also optimistic. I'm also, I think, 3/4 of the way through my beer. So, but I like Alice. I'm glad that there's a proceeding underway so that we can get kind of like all of the facts and all the opinions on the table. No one might like the way this was written. People might be surprised, but it's a forcing function to get everyone's opinions in. And I don't know if anyone's ever kept track of, how many responses the FCC has received from the proceeding, but this is going to probably rank up there, as one of the big ones. And they're going to hear from constituents that likely have never filed with the FCC before. So it's going to be very interesting. I think they're going to need more than 30 days to interpret the first round, if not the second round of comments. But the cross current that's going to happen in the second round will almost be more entertaining, I think, to read, once everyone reads your first submission. So glad the conversation is happening. Glad that CBDX is, part of that discussion. And I got to believe that very wise people will do the right thing.
Yeah, I mean, we're very optimistic. We're encouraged that they opened the proceeding. We're encouraged that they've proposed allocation for CB2X that we've been asking for months. That's all very encouraging. To retain the entire band, we think it's going to be really important to make a compelling case. We think it revolves around 5G and the capabilities for automated vehicles. But making that very compelling case is going to be important, which we intend to do. And then the other piece of it is deployments. It can't just be a few companies saying that. We're going to need sort of a lot of companies coming forward with deployments and really making the case to the FCC that full 75 megahertz will be utilized, because I think that's been the biggest concern so far.
So with that, we're going to conclude, but because we have drinks and we're going to be putting odds, and people can bet on different outcomes. No, just joking around. I'm not going to do that. Oh, yes, questions. I'm sorry. We can do questions. Please. Back here. Does anyone from Safe out? Do you have a mic?
We'll share one.
Hi, Ari Fitzgerald at Open Mobile. The FCC and the NPRM asked for comment on why the 5.9 gigabit band was necessary for providing these services, and I think it's important for the industry to sort of talk about that. I've heard a little bit about the economies of scale, global harmonization of things already tonight, but some people are sort of asking the question, why can't CB2X be delivered over the traditional cellular frequencies? Anyone sort of address that?
Maybe because I'm not sure the mic picked it up, so for the audience, maybe just repeat some of the question in your answer.
Yes, I think the question was, why can't cellular V2X be delivered over traditional cellular networks? Why does it need the 5.9 gigahertz band? So CB2X operates in two modes. It has a peer-to-peer mode, which is direct car-to-car communications, and then and that accommodates V2B, V2I, V2B, V2P services. And then there's another mode, which is over the network, V2N, which is less time sensitive for that. For the peer-to-peer services, the 5.9 gigahertz band is globally harmonized, as you mentioned, for that capabilities, and we want to be able to take advantage of the economies of scale that evolve from using globally harmonized spectrum for that purpose. And I think there might have been kind of a bit of a misunderstanding in the NPRM in the way they described that. And so we will, in our responses to that, we will address that little bit of a perhaps misunderstanding that you could just use regular cellular network spectrum for this purpose.
Another question? Other questions? Please, over here.
Yeah, I was just curious since.
Can you just say who you are?
Oh, yeah, my name is John Partham. I was just curious, you had mentioned that the FCC had seen the spectrum, excuse me, line follow for this, and there's some programming and regulatory, I guess, concerns that come up for implementing all this stuff. So in terms of, there's obviously a lot of advantages that can be had through implementing all of this and using the full spectrum, but what's the timetable that's given to the FCC in terms of, we have all these advantages, but there's a lot of hurdles too, but we can get this done by, or whatever. I know there's different applications, but just curious what's being sent back on that.
I don't know, I guess I don't understand it, but are you asking for what is the envisioned timeline from this proceeding moving forward, or?
No, I mean for some of the technology you guys are talking about, because you mentioned all the advantages of it. I'm just curious for the deployment implementation. Yeah.
Well, I think the deployment's a matter of commitment. I think, as Ed mentioned, many people are waiting for regulatory certainty, before you kind of make that commitment. We've made a commitment because we believe in the technology, and we felt that you can either wait, or by maybe declaring it compels others, to join with you. So, in the organization that both Qualcomm and Ford are part of, 5GA, there are other OEMs as well. I think arguing on behalf of CBX and hopeful that it'll come through.
So I work with a lot of IOOs, and their perspective, at least many of their perspectives,
IOOs are
infrastructure owner operators, sorry, state DOTs, local agencies, things like that. And many of their perspectives is, while many have already purchased, as you heard, there's 498 projects stacked up at the FCC right now waiting for licensing. And many of them are ready to pull the trigger. They've got money programmed for that. And quite honestly, that money doesn't stay, right? In a government world, you don't use it, you lose it. And so, they're ready to go. From at least an infrastructure perspective, I believe.
Can you answer why does it take so long? 498 applications are in. What's taking so long to get those out?
My understanding is that the FCC suspended the license process, approving licenses technically in September of 2019. And so at this point, they're not approving any licenses for the SRC, to be clear, except for maybe Channel 180. And I know that some of the agencies I work with are reissuing their license for Channel 180 only to see if they can get a license for that.
Let me just add to Steve's comments really quickly. So OmniAir Consortium, we have members around the country. So we have one member that does 80 shuttles, right? And so for every 80 shuttle project in the US, you're required to have a V2I capability to crossing a public street. And they're frustrated because so many of their partners are not able to launch the projects because the FCC has not issued licenses. There are, and so this is impacting not just connected vehicle projects or emergency vehicle preemptions, but some of the things you wouldn't think of. And some of these 80 shuttles, which are ready to go and are very innovative, aren't able to start because this issue is still up in the air with the commission. I think having some certainty and moving that licensure process forward is incredibly important.
I guess, is there one last question? So then I just, we talked very wonky about this spectrum and these signals, but, I just go back to the numbers, 3.3 billion gallons of gasoline, which of course comes from oil, which is wasted fuel in traffic, $280 billion in the costs of accidents, 800 million in indirect costs. I mean, think of that. About $1 trillion, over $1 trillion. But most importantly, 36,650 people have died. and several million injured a year. So it's just really important to put this into perspective and to make sure that as we stand on the cusp of solving these problems, industry and all your great companies who are the next drug companies in many ways going to save the lives of the future of all of us and the people we know. I think just giving you the space to do this would be great and really important for the FCC to look at this perspective. Thank you. Thank you all.
Thank you.
Let me say one thing before we break. I think this event wouldn't happen without some fantastic staff from multiple organizations pulling this together. So I want to thank Greg Rogers with SAFE, Alyssa with SAFE, David Wynn from Connected CarTalk DC,
People that work for
and
you.
Kate Oldham with OmniAir Consortium. And so just to ask everyone to give a round of applause.
How are you doing? I think we met a long time
Yeah,
ago,
yeah.
like in 2008 when we started doing digital.